Hi, welcome back to Learner's Academy. In this video, we're going to learn the concept of functions. Now, outside the context of mathematics, the word function generally describes the purpose or role something serves. However, in the world of math, a function carries a more specific and structured definition. Mathematically speaking, a function is a rule or relationship that links one set to another in a specific manner. A set, by definition, is simply a collection or grouping of objects. Typically, sets contain numbers, but they aren't restricted to that. They can also consist of letters, names, or virtually any items you can imagine. Sometimes, sets are illustrated visually like this, but more commonly, mathematicians use a special notation where the elements of the set are listed within curly braces and separated by commas. Sets can be either finite members, meaning they have a limited number of elements, or infinite, meaning they continue indefinitely. For example, a set containing all 12 months of a year is finite, whereas the set of all natural numbers goes on forever, making it infinite. Alright, now that we know a set is just a collection, how does a function connect one set to another? To make this idea clearer, let's assign special names to the two sets. We'll call the first one the input set and the second one the output set. A function, then, is something that takes each element from the input set and associates it, or maps it, to an element in the output set. In math terminology, the input set is typically referred to as the domain, and the output set is called the range. Often, these inputs and outputs are organized into what's called the function table. A function table usually has two columns. One column on the left displays the inputs, and the one on the right shows their corresponding outputs. Above the table, the function is usually written out as a mathematical rule or procedure. For instance, suppose the input set is a list of polygon names: triangle, square, pentagon, hexagon, octagon. The rule for our function could be output the number of sides. Following this rule, inputting triangle would give us 3 as the output. Inputting square would yield 4, inputting pentagon would produce 5, and so forth. This particular function pairs the name of a polygon with its corresponding number of sides. Pretty straightforward, right? However, most functions you'll deal with in algebra are a bit more abstract. Typically, they relate one variable to another through an equation, like this: y equals 3x. In this case, we treat x as our domain, the set of all possible inputs, and y as our range, the set of outputs. Thus, y equals 3x represents a basic algebraic function. Just as we did earlier, we can create a function table for this function to demonstrate the input-output relationships. Although x could be any number, for simplicity, let's choose the inputs 1, 2, and 3. Let's work through them. If we input the value 1, in other words, if we substitute the value 1 for the x in our equation, then we get y equals 3 times 1, which simplifies to y equals 3. And since y is our output variable, we put a 3 in the output column. If we input the value x equals 2, in other words, if we substitute the value 2 for the x in our equation, then we get y equals 3 times 2, which simplifies to y equals 6. And we put a 6 in the output column. Lastly, if x equals 3, we can calculate y is 3 times 3, which equals 9. And we have the output, 9. Do you notice the trend? Every time, the output exactly triples the input, which makes sense given the rule of the function, y equals 3 times x. Now that we've seen a few examples of how functions work, it's crucial to understand an important limitation about the functions we must know. To explore this further, let's consider the equation, y squared equals x. As before, x will represent our inputs, and y will represent our outputs. Since y is the output, it helps to solve the equation for y. Taking the square root of both sides gives us y equals plus minus under root x. Because of negative numbers, we need to take both the positive and negative root of x. Since there are two possible solutions to our equation, meaning that for each positive input, there are two corresponding outputs, one positive and one negative. For instance, if x equals 4, the principal root yields y equals 2, but the negative root gives us y equals minus 2 as well. Thus, the input value of 4 produces two outputs, 2 and minus 2. Is this acceptable for a function? Short answer, no, it isn't. Remember, a function must assign exactly one output for each input, and here, a single input is giving two different outputs. Therefore, it is not a function. This is known as a one-to-many relationship, and it's not allowed in the definition of a function. Although one-to-many relations do occur in math, but they aren't classified as functions. So a function doesn't just relate a set of inputs to a set of outputs. A function relates a member of an input set to exactly one member of an output set. Or, in other words, each element of the domain must map to exactly one element of the range. On the other hand, the equation y equals 3x we discussed earlier is indeed a function, because every input leads to one, and only one, output. Let's examine another equation to see if it meets the criteria of a function. Y equals x plus 2. Again, we'll treat x values as inputs and y values as outputs. To check this, let's generate a quick function table using x values ranging from -3 to +3. You might recall from previous video on graphing that each pair of input and output values forms an ordered pair, x, y. Thus, we could rewrite the function table as a list of ordered pairs if we wanted to. It's an x value followed by a y value, right? Moreover, these ordered pairs can be graphed on a coordinate plane. You can graph a function. By plotting the points from the table and connecting them, we obtain a straight line. This is an example of what's known as a linear function. In algebra, functions can take many forms with a variety of interesting graphs: quadratic functions, cubic functions, trigonometric functions, and many more. Even though their graphs might look like complicated curves or intricate lines, in fact they are functions, as long as they pass an important test, the vertical line test. Recall that functions must produce only one output for each input. The vertical line test helps us verify this graphically. Here's how it works. Imagine drawing a vertical line through the graph at any x value. Observe how many times it crosses the graph at any given position. If, at every x value, the vertical line touches the graph at exactly one point, then we are having one value of y for that specific value of x. Or, we can say that for each input, we have one output, one x, one y, right? Therefore, we can say that as there is one output for one input, therefore the graph represents a function. If, however, the vertical line ever crosses the graph more than once at the same x value, the graph fails the test and does not represent a function. Looking back, all the graphs we examined for functions like y equals 3x and y equals x plus 1 pass the vertical line test, confirming that they are indeed functions. But let's see an example that fails the vertical line test. Consider again the graph of y squared equals x. Here's what happens. At some x values, particularly negative ones, the graph has no points, which is acceptable. At certain x value, which is origin, the graph has exactly one point. That's also acceptable. However, for positive x values, our vertical line crosses the curve at 2 points. This dual intersection means two outputs for a single input, thus violating the rule for functions. Hence, y squared equals x does not represent a function. Before wrapping up, there's one final thing we need to address: function notation, which often confuses beginners. Until now, we've been writing functions like y equals 3x and y equals x plus 2. However, in many textbooks and math references, you'll see functions written like f of x equals 3 times x, or f of x equals x plus 2. Why replace y with f of x? And what does it even mean? Well, f of x simply stands for function of x and is a different way of expressing the output variable, previously y. This notation means that a function, named f, takes an input value, named x, and gives an output value, named y. It's still the same function, just presented using more formal mathematical language. So instead of writing y equals 3x, we can write f of x equals 3x. They mean the exact same thing. In this notation, the f just stands for the function itself. The parentheses x remind us that x is the input to the function. The problem with this notation is that you could easily misinterpret it, with variable f being multiplied implicitly by a variable x to give an answer of y. But that's not the case here. In this case, f is not a variable, and it is not implicitly multiplied with variable x. Instead, f is the name of the function. While the problem could have been solved if the mathematicians just used the entire word function as the name, and then use the name's input and output instead of x and y. However, it is so in the textbooks and should not be confused with variables. Okay, but why use f of x instead of variable y? Here's the deal. Using f of x highlights the fact that you're dealing with a function with a specific input variable x, and not just an equation. And it gives us a handy notation for evaluating functions for specific values. For example, you could start off by saying, let the function f of x equals 2x plus 3. So to find the output for input, x equals 2, then we would ask as, what is f of 2? Notice we have replaced the input x with 2. So we will substitute 2 in place of any x that is in the function. For this function, that would mean f of 2 equals 2 times 2 plus 3, which turns out to be 7. Similarly, we can do this for other values too. F of 3 equals 9, and f of 4 equals 11. All right, so that's the basics of functions in math. Functions relate an input value to exactly one output value, and the set of all input values is called the domain, while the set of output values is called the range. In algebra, functions typically come in the form of equations that can be graphed on the coordinate plane by treating the input and output values as ordered pairs. These are just the basics of functions, and there's a lot more to learn about functions in the coming videos. Remember to practice what you've learned in this video by doing some practice exercises. As always, thanks for watching Learners Academy. See you next time with more amazing videos.